the nucleus of an atom is split into two smaller nuclei, releasing a large amount of energy in the process. Fission weapons typically use a small amount of fissile material, such as uranium-235 or plutonium-239, to initiate a chain reaction that releases energy. When a fissile atom is struck by a neutron, it can split into two smaller atoms, releasing additional neutrons that can strike other fissile atoms and continue the chain reaction. The energy released in a fission explosion can cause extensive damage to buildings and infrastructure, and it can also cause radiation exposure that can lead to long-term health effects. Fusion weapons. Fusion weapons, also known as thermonuclear bombs or hydrogen bombs, use the process of nuclear fusion to release energy. Nuclear fusion occurs when two atomic nuclei are fused together to form a heavier nucleus, releasing a large amount of energy in the process. Fusion weapons typically use a small fission bomb to initiate a fusion reaction in a second stage. The intense heat and pressure generated by the fission bomb compress and heat a mixture of hydrogen isotopes, causing them to fuse and release energy. Fusion weapons are much more powerful than fission weapons and can release significantly more energy. The energy released in a fusion explosion can cause catastrophic damage to buildings and infrastructure, and it can also cause radiation exposure that can lead to long-term health effects. Nuclear proliferation. Nuclear proliferation is the spread of nuclear weapons to countries or non-state actors that do not already possess them. The proliferation of nuclear weapons poses a significant threat to international security, as it can lead to nuclear conflict and instability. The international community has taken a number of steps to prevent the proliferation of nuclear weapons, including the Non-Proliferation Treaty, NPT, which aims to prevent the spread of nuclear weapons and promote peaceful uses of nuclear energy. The NPT has been signed by over 190 countries, and is the cornerstone of international efforts to prevent the spread of nuclear weapons. Radioactive waste is a byproduct of nuclear reactions and nuclear medicine. It is highly hazardous and poses a significant threat to human health and the environment. The safe storage and disposal of radioactive waste is a major challenge for the nuclear industry. Types of radioactive waste. Radioactive waste can be classified into several types based on its radioactivity, half-life, and other properties. The main types of radioactive waste are low-level waste, waste with low levels of radioactivity, such as contaminated clothing, tools, and equipment. Intermediate-level waste, waste with higher levels of radioactivity, such as reactor components and contaminated materials from nuclear medicine. High-level waste, waste with the highest levels of radioactivity, such as spent nuclear fuel and the waste generated from nuclear weapons production. Radioactive waste management. The nuclear industry uses a variety of methods to manage radioactive waste, including storage, transportation, and disposal. Storage. Radioactive waste is typically stored in specialized containers, such as steel drums, that are designed to prevent leaks and protect against external hazards. The containers are often stored in secure facilities, such as underground repositories or above-ground storage facilities. Transportation. Radioactive waste is transported using specialized vehicles that are designed to protect against radiation exposure and prevent leaks. Transportation routes are carefully planned to minimize the risk of accidents or incidents. Disposal. Radioactive waste is typically disposed of in specialized facilities, such as deep geological repositories, that are designed to